If two triangles are congruent to each other, then all of their corresponding parts are also congruent to each other. Last chapter, when we had corresponding angles, it meant in the same spot. When we have corresponding parts between triangles, it means in the same spot. So if triangle ABC, the symbol for a triangle is just a triangle, is congruent to triangle DEF, then all of the corresponding parts between those two triangles are congruent. If we look at A is a point, but that point in the triangle creates a vertex of the triangle, and the vertex of a triangle is just an angle. And A is the first letter, and D is the first letter in our congruent triangles. So A corresponds to D, which means that angle A corresponds to angle D. Angle A is congruent to angle D because they correspond. They're in the same spot between my two congruent triangles. If this is true, then I can conclude that I have a pair of corresponding congruent angles. My second letter, B, also forms a vertex of the triangle, and it forms an angle, and it corresponds to E. So angle B is congruent to angle E. And C is my third letter. It corresponds to angle F. Now, triangles are not made up of just angles. There's also sides in those triangles. So the sides of the triangles that correspond are also congruent. If we go back to our letters, AB, the segment between A and B corresponds to DE. So segment AB is congruent to segment DE. And our second and our third letters, BC, correspond to EF. So BC is congruent to segment EF. And our first and our third, AC, the segment between AC corresponds to the segment between DF. So segment AC is congruent to segment DF. If two triangles are congruent, then all 6 of their corresponding parts are also congruent. When you look at two congruent triangles, you have to make sure that you are lining up the correct corresponding parts. If we look at point R, it forms a vertex, it forms an angle, and it has one arc mark, and it corresponds to angle A. Angle A also has one arc mark. Now if we look at vertex S, angle S, it has 2 arc marks. It looks like it should correspond to N. But the way that this second triangle is drawn, S does not correspond to N, even though they're in the same spot. S actually corresponds to M. M is the angle that has 2 arc marks. And T, even though it looks like it should correspond to M, corresponds to N. A triangle can be rotated or turned or flipped and still be congruent to another triangle, as long as the parts correspond. If we look at the side lengths, the segments, RS is between the angle with 1 arc and 2 arcs. So if we find the side between 1 arc and 2 arcs, we have AM. So RS corresponds to AM. And ST between 2 arcs and 3 arcs corresponds to MN between 2 arcs and 3 arcs. And RT corresponds to AN between 1 arc and 3 arcs, between 1 arc and 3 arcs. So if we were to name these triangles congruent to each other, the order does make a difference. If we name the first triangle RST, then we have to name the second triangle correctly. R corresponds to A, and S corresponds to M, and T corresponds to N. Don't trust the way the picture looks, trust what the picture tells you. If we switch the order of that first triangle, SRT, SRT corresponds to, is congruent to triangle M, because S corresponds to M, A, because R corresponds to A, N, because T corresponds to N. If we switch the order again, TRS, T corresponds to N, R corresponds to A, S corresponds to M. We could keep going and keep changing the order of this first triangle, and as long as we kept correspondence in that second triangle, we could make another set of congruent statements.